Good evening all. Welcome to Life Made Up of Questions. Today we are having Professor Dr. Gunasekaran Tangavel, who is currently the Program Director, Electronics and Communication Engineering, Electrical and Electronics Engineering Department, University of Technology and Applied Science, Muscat Sultanate of Oman. He's having a lot of years of experience in teaching as well as administrative area in education, academia. He has a lot of publications to his credits, a lot of patents also. So welcome you, sir, for this session on 5G communication. It will be beneficial for the students and the faculty. Welcome you.
Good evening, sir. Thank you for the opportunity to share my little knowledge on 5G with your students. Thank you.
So you'll be sharing the screen, right?
Yes, sir.
Okay.
Yes. Is it visible?
Yeah, it's visible. It's visible.
Okay, sir. We can start.
Okay, fine.
Yes, sir.
You're able to share, right?
Yes, sir. I could be able to share. I just minimized it.
Okay.
Now
Okay.
the screen is in shared view only.
Okay. Okay. Fine.
Yes, sir.
Because 5G in the sense now from 1G, 2G, 3G, 4G, LTE, we are entering into the 5G. So a lot of curiosity will be there. What are the basic ideology of 5G, the technology? Then what are the advancement in the case of the basic technology of OFDM, then combining with the millimeter antenna, the wider spectrum, how the spectrum utilization will be. So shall we start, sir?
Yes, sir. Please.
Yes, sure, sir. Please start.
Okay. Sir, actually, we know we have been moving towards 5G. Now the 6G also going to emerge very soon. But I'm going to give a history of the first generation, second generation, third and fourth generation wireless network, since we know we have been seen practically and we have been experiencing by using those technologies. So we will take those technologies as a benchmark to understand what is 5G. Okay, so I will share my screen and I will tell you things. Can you able to see my PPT?
Yeah.
Okay. It's opening now. So I have made like a presentation, but I will answer your question by.
No problem. You can continue. We can have the interactive.
No. It may be interactive. I like it. I like this one. So I will. Am I visible?
Yeah, it's visible, sir. Please carry on.
No,
Yes.
my face is also visible. Am I right?
Your face is not visible. Not an issue. No problem. Yeah. Okay. Yes.
Okay. So actually, this 5G is not simply like 4G plus 1. I'll tell you what is this. Okay. See, when first generation wireless networks are emerged, deployed, and it has been used only for voice calls. We know that. And the communication technology used here is amplitude modulation. Okay. And this is only intended for voice call. Okay. And there is no value added services. When 2G emerged, when the 2G technology came into functioning, almost 70 to 80% of the 1G towers have been completely replaced. But still, we have 30% of 1G towers with us. I will tell you why. From 1G to 2G, okay, we have been added with the value-added services. And along with that, a small packet radios have been introduced like a GPRS. Okay, then when 2G to 3G, the 3G technology is deployed to functioning. Okay, so almost 80% of the 2G towers have been replaced. Similarly, when 3G to 4G, almost 75 to 85% of the 3G towers have been replaced. But when you are shifting from 4G to, I won't use the word shifting, when you are emerging this 5G technology, we are not going to completely replace this 4G technology, unlike these methodologies. So 5G is a totally new network technology, and it is for a totally new environment. What is that? 5G promises to provide a high capacity, the data rate in the order of around 10 to 50 gigabits per second. With the latency is nothing but end-to-end delay. That is response time of the device, which is theoretically 1 millisecond. So you can see the data rate, it is around 10 to 50 gigabits per second. Is it possible with the coaxial cables what we have with us? The core network, it is almost connected to the base stations and your mobile switching centers, okay, via the fiber optic coaxial cables. But this coaxial cables are not sufficient to provide such a data rate. So these coax must be replaced by optical fiber cables. So this is the first and foremost requirement of the core network in terms of deploying this 5G. That's why in India, replacing this coaxial networks to coaxial core to fiber optics, at least 70% of the core network must be replaced with this fiber optics, then only we can able to provide this particular speed. So in general, this 5G technology is totally new network technology in terms of the core network. So that triggers the network to be operating with that high speed. So that is the one of the primary requirement to deploy this 5G network. And remaining advantages, I don't want to spend much more time. Let us go to the immediate technical task when we discuss about this 5G, the spectrum. As Professor Hari has given insight about millimeter wave and also OFDM, the spectrum of this 5G is divided into two parts. One is FR1 and FR2. Why we have to talk about the spectrum? Any communication system, the two major resources are power and the bandwidth. Why we are paying money to the service providers? We are utilizing their power and the bandwidth. So these two are the parameters, are the major resources in any telecommunication network. So how effectively we are going to use this power and bandwidth, okay, will decide the quality of service, efficiency of the network. So compared with this 1G, 2G, 3G, 4G, let us take the latest trend, which is called advanced LTE, which is called a 4G network. Okay. The operating frequency, or you can call it as a center frequency with respect to digital communication engineers, it is 2.4 gigahertz. This 5G is operating at various frequency ranges. The first one is FR1, which is divided into two portions. One is FR1A, another one is FR1B. So this FR1A is at most in the lower band, or we can call it as sub 1 gigahertz band, which is close to your 2G spectrum. We know what is 2G spectrum. It is in the order of 800 megahertz and 900 megahertz. And FR2 is the highest range of your 5G, which is called millimeter wave spectrum. So the ITUT, International Telecommunication Union, telecommunication sector, okay, then along with 3G partnership program, okay, both combined together, they have been fixing up the frequency ranges from sub 1 gigahertz to millimeter wave. Why we need a different spectrum for implementing this 5G? The first and foremost thing, the advantages or the bottlenecks of this particular millimeter wave. These millimeter wave spectrums are having enormous bandwidth. We know that any network which has higher the bandwidth, the data rate, the capacity, digital capacity, the data rate is always directly proportional up to a certain limit. Let us see the limit. What are the limits? But the limitation of this particular millimeter waves are, these waves are short waves. Frequency is very high in the order of 18 gigahertz, that is sub-millimeter wave. Theoretically speaking, you can go up to 300 gigahertz. But the millimeter wave, the component availability may be up to say 56 or 60 gigahertz only. Okay. So these frequency ranges are having short wavelengths. So these short wavelengths are capable of producing super fast data in the order of 10 gigabits per second, 50 gigabits per second, like that. But the problem is these waves have a larger path loss and cannot able to penetrate through buildings. It is not transparent. So these waves cannot able to penetrate through buildings. And also the Earth's magnetic field is strongly influencing these waves to travel along the ground wave structures also. Therefore, the coverage is very, very less. But we can get enormous data. Throughput is very, very high. Unimaginable throughput. But the coverage is very less. In the meantime, if you want to cover a large geographical area, then only the number of subscribers will get increased. So the current or existing mobile network operators, they don't want to shift from 4G to 5G. The reason behind that is at millimeter wave frequencies, the coverage is very less. Hopefully you understand the meaning of the short wavelengths. So we are using two spectrums here. One is the sub 1 gigahertz spectrum, which is of 800 megahertz to around 1.1 gigahertz or up to 1 gigahertz, we can say. So these waves are long waves. So these long waves can able to penetrate through buildings. So we will get a greater coverage. In the meantime, the bandwidth is very, very less. So the data rate, we cannot able to achieve more than a certain limit. So the components are available at this frequency range. So deploying this particular frequency is very easy. So you won't get any deviations for the establishment of the network, the user equipment, everything, no worries about it. But you have to sacrifice the speed. Who will be ready to buy a network with less speed? So the 3GPP release 1516, you can go through it. It is available in the Google. You can Google it. So it will be giving a FR1 band B, which is slightly greater than your 2.4 gigahertz. So up to 7.125 gigahertz, you can able to transmit information. The user equipment, the devices are available at this frequency Y, which is close to our C band. We know our C band is 4 to 6 gigahertz. Most of the satellite transceivers are operating at this frequency band. So getting user equipment or getting the devices for operating this particular range of 7.125, it is a mid-band frequency where you are balancing the coverage and the speed. So hopefully you understand the reason for going to the millimeter wave, and still we are stick with this particular FR1 lower band. The reason is the coverage. That's why the 5G has promises to provide applications in the indoor, short coverage applications, smart cities, smart agriculture, electrical vehicles, autonomous driving vehicles, where we can use this millimeter wave, not for mobile broadband. If we want to use it as a mobile broadband, we need to change or we need to adopt a lot of bottlenecks to be open, and we have to get different solutions. Still research is needed on it. Hopefully, Professor Hari, I have explained about the spectrum, the one which you have been asked for. You can go for the next question.
Yes, sir, sure.
I have answered your question.
So regarding the, I mean, now students are very much fascinated regarding the 4G then 5G. So what will be the device connectivity for this 5G? The underlying technology, we got the idea, the wavelength, everything. So what will be the connectivity as well as the downloading speed? All they are more user end concepts. That's why I'm asking.
Sure. Let us see that. So actually, this is something like a critical question. The answer may be a broad answer. So I will tell you the downloading speed of your 4G. You know that I need not explain to you. We know what is the downloading speed of this 4G. Theoretically speaking, the downloading speed is up to 300 megabits per second. Honestly speaking, what is the maximum download speed you are getting with your 4G? Is it equivalent to 300 megabits per second?
No.
No. What is the maximum, sir, in your area? Maximum downloading speed?
Yeah, it will be varying. Yeah, as you have mentioned, it will be varying.
So during the peak time, the peak hours, if you're getting a 5 Mbps to 10 Mbps, you will be say, okay. Am I right, sir?
Yes.
But why the maximum is 300 Mbps while designing? When it is going to peak hours, why we won't be able to achieve this theoretical speed as a practical one? What is the reason behind that? As I already mentioned, the core network is the one of the reasons to connect your user equipment with base stations and the servers are coaxial cable. We know the speed limitations of this coaxial cable. That's why from the beginning I mentioned we have to replace this coaxial cable with fiber optics cable, at least 70% of the networks. Then only we could able to get the rugged data rate. So that is the requirement. Okay. Then has been asking for something called the connectivity. So before going to discuss about the applications, let us see the connectivity, especially when we use for the broadband, when the downlink path. For that, we should have some knowledge about the channels and the channel bandwidth allotted for your 4G network. You see the bandwidth allotted for each LTE network, one channel is having almost a 20 megahertz bandwidth for LTE. I hope you all familiar about what is this VoLTE. Unlike 3G, your voice is also going like a packet. Like your VoIP, the LTE carries your voice into packets also. So keep that in mind. Let us come and discuss this one later. So the one channel bandwidth is 20 megahertz. So the connectivity of this 5G, as per the release 16, 3GPP release 16, operation of this 5G is in two mode. One is in the standalone mode of your 5G, operation in the non-standalone mode. What is this non-standalone mode? So let us come to this non-standalone mode first. In non-standalone mode operation, this 5G network completely depends on the 4G network. So the backbone for this 5G is 4G. We are combining 5 channels of your LTE, each having 20 megahertz bandwidth. So 5 into 20, you will have at least 100 megahertz bandwidth, which is one channel bandwidth of your 5G. Then you started to increase the bandwidth and your 4G now is operating in 5G mode. This we call it as non-standalone mode. In this particular connectivity, the base station doesn't have any problem. We know the reason. You have enormous space, you have enormous computing power, you have enormous, what you can say, the processing elements to be added. Consider your mobile equipment. Like this is the internal architecture of a mobile phone, which I have been downloaded from a source, from the Samsung. Okay, you just look into the phone. How can you able to certainly operate from a 20 megahertz to 100 megahertz bandwidth. So we need to discuss about yes, something called the dual connectivity. So where user equipment, especially in the application of enhanced mobile broadband deployments in the non-standalone mode, your device have to switch from 4G 20 megahertz to your 5G 100 megahertz bandwidth. So this particular dual connectivity increases the RF interference challenges. So the non-standalone mode will continue to present challenges for handset, and the mobile operator have to be converting the whole non-standalone mode into a standalone mode until this problem has to be existing. Meaning the mobile operators are going to replace all your 4G towers with 5G, then only this particular problem will be resolved. Why? What is the challenge behind this dual connectivity? You just take a simple RF amplifier, which is operating at a band of 2.4 gigahertz with the bandwidth of say 10 megahertz. That is the center frequency of your LTE. Certainly, you are operating at a frequency band. It may be increased to 2.4, the same bandwidth. But you are increasing the number of frequency blocks. So your 10 megahertz bandwidth is around 5 channels you are combining. So it will become 50 megahertz, the center frequency of your, what you can say, 5G. Do you have your RF amplifier operating this such a wide range of bandwidth? And you have to maintain the linearity limit. What is the linearity limit? If you keep on increasing it's a theory, we know that. If you increase the bandwidth of any amplifier, you have to sacrifice the gain. Your gain automatically reduced. And where the power will go? It will create lot of irregularities with the band. That creates the non-linear operations of the power, which will be exceeding the limits provided by the standards. Regulatory limits. That's why we have TROI, Telecommunication Regulatory Authorities of India. TROI. They have limited its power as well as the bandwidth of the mobile operators. So these are all some of the challenges which will be considered to design the dual connectivity 5G mobile networks. Okay, Professor Hari?
Yes, sir. Carry on, please.
Yes. So this is the way we have to be calculate the bandwidth, and you have to check with the dynamic spectrum sharing. What is this dynamic spectrum sharing? So this is one of the power management solution. Say, I will tell you something. So for fixed wireless networks, hope you people heard about the word called femtocells. In a particular access point, if a user wants to get more bandwidth, what the existing 4G is doing, it is simply adding frequency blocks. Adding the number of frequency blocks will increase the bandwidth for that particular user. Obviously, the payment, the cost, the billing rate also to be increased. So this we call it as femtocells only for fixed wireless access. In 4G, there is one more word, technical word they use, carrier aggregation. What is this? It's like simply increasing the bandwidth of a certain range, bandwidth at a certain rate to cope up with the dynamic spectrum sharing for the high-speed users, or you can say the one who wants to download a video or a movie. So at this particular stage, the power management challenges, how to be enter into the mobile networks. Even with the fixed mobile networks or fixed mobile access or the regular mobile communication users, the peak to average power ratio. Why we have to consider this peak to average power ratio? You take any communication system, either your transmitter side or your mobile side, that is your receiver side. The first and last stage of the communication system is power amplifier. We know that power amplifier, these RF power amplifiers, which are all almost made up of your non-linear devices. So these power amplifiers have to operate within the regulatory limits, and it has to maintain linearity. What is this linearity? What do you mean by that linearity? You check this 1 dB compression point of your power amplifiers. Either you take any type of power amplifier, not only BJT, you take JFET or MOSFET, or nowadays your CMOS VLSI plays a vital role to design these power amplifiers or nanotubes, whichever may be. If we keep on increasing the input power, the output power has to increase linearly, theoretically speaking. But no device will do that. Every device hits is breakdown. So keep on increasing the input power, the output power becomes constant. We call it as the saturation region. We know that. So we have to stop our input power at this particular region. Then the allowable range from between the linear to non-linear region is 1 dB compression point. So all your power amplifiers must obey this criteria to satisfy the linearity limits and regularity limits provided by the telecom operators. Hopefully you understand what I mean here. We are not only dealing with the wireless connections with the antenna and its subunits only. We have to be concentrate on more on the transmitter and receiver side to balance the power and the bandwidth. Otherwise, we have to pay more amount when you are utilizing this 5G. Okay, so this particular consideration will increase the linearity limits, meaning you will get more harmonics. Then what will be the result if you increase the more harmonics? The leakage power will become more and more. Then there is a technical term given by the standardized regulatory authorities, which is called specific absorption rate of the human body. It is measured by the unit called watts per kilogram. Watts per kilogram. So it will be given by the standard. You can refer the standards, for each phone have its own specific absorption rate. If you buy a mobile phone, there will be a booklet along with your mobile phone. At least we engineers, we educated people, and then the professors are someone who is on that particular era can check that book, just to open and read the book, especially this particular word SCR, specific absorption rate of the human body. And you can check your weight. Okay, for example, I'm 68 kg. What is the amount of power, electromagnetic energy I can able to observe without making any heat in my body or any heat in the cells? Have you used your mobile phone continuously with 15-20 minutes attaching with your phone body, with your human ear? You can feel the heat. We know that rather than a straight conductor, a bent conductor absorbs and radiates more electromagnetic power. We know that. Check your human ear, eyes, heart, kidney, everything looks like a curved surfaces. It will absorb more electromagnetic power, which will create heat, like your microwave oven, how it is rotating, producing heat. The same aspect have to be occurring in this particular conditions. So we have to be carefully choose these power amplifiers while interfacing your antenna with this transmitting units. Okay. So this is the another constraint which we must be considering while designing this particular 5G networks. Professor Hari?
Yes, sir. Carry on, carry on. Yes, sir.
You can proceed with your next question. Hopefully,
no, because all these technical aspects are very much interesting to hear. So I think we can have the interaction at the end. You can carry on. Then we can have a discussion at the end. That will
sure.
be okay, sure.
Okay, sure. So now we'll go back again to the scenario which we have been discussing with respect to the 1 dB compression point of the power amplifiers. And this potentiality, which reduces the efficiency of the transmitter chain and creating challenging high linear power requirements for the power amplifier design. So this is the one which I have been explained. Now let us come to the second scenario. When we take into this particular word, okay, as I said, what determines the capacity of your wireless networks? For example, if you are taking your enhanced mobile broadband, the minimum data rate guaranteed for this 5G is 10 gigabits per second. Maximum you can go up to 15 gigabits per second. And there is one more application which is called ultra reliable low latency communication, which indicates the industrial automation, your autonomous driving vehicles or self-driving vehicles, remote manufacturing. I hope you students might hear about the word called cobots, which is nothing but collaborative robots. In the medical field, these robots plays vital role, which will be collaborating with the human body, human doctors or human trained technicians. I hope you, if you have a time, just look at the Arrow Lab, Arrow, AURO, Arrow Labs by Madurai, Aravind Eye Hospital, Madurai. They have, I think, 8 to 10 cobots, collaborative robots, which are manufacturing the lenses, cataract lenses, and they're exporting it. The productivity is keep on increasing by means of these cobots, the machine-to-machine communication with very low latency. Latency means the response time, as I already mentioned. What is that low latency? 5G promises to provide 1 millisecond latency. 1 millisecond latency, theoretically. And the last application, which is the very famous, and we are all very firm with that name, which is called Internet of Things. Even Internet of Medical Things, you can name it. Massive machine type communications. The tiny wirelessly connected sensors will do wonders with the applications like smart housing, smart buildings, smart agriculture like. So where 1 million connections per kilometer is the target provided by the some of the service providers for its deployment. So these three categories are the main applications of the 5G. Here, let us take this enhanced mobile broadband, meaning at the given bandwidth, we are going to increase the capacity of the network. So take this fundamental formula, which is used to calculate determines the capacity of wireless network. We call it as Shannon channel theory. It's a very fundamental theory. I'm going to relate this theory with the 5G network.
Yes.
The capacity of this wireless network is directly proportional to bandwidth, directly proportional to a logarithmic scale of SNR. Why Shannon take a logarithmic scale? Shall we say, if you keep on increasing the signal power, will you increase the capacity even though it is directly proportional? No. He used a term called logarithmic scale. We academicians know that the advantage and disadvantage of this logarithmic scale. For example, I want to plot a data which varies from 10 to 1 lakh. Do we have scale, graph sheet, plotters to plot this range 10 to 1 lakh? So that's why the semi-log graphs came. One side you keep as such, the variation. The other side you take logarithmic. Actually here digital communication, the base is 2. For make you to understand, I'm taking base 10. Calculations becomes very easy. So we know log 10 becomes 1. Log 10 1 lakh becomes 5. So now your scale is compressed. It is an advantage as we studied like ALA compounding, MULA compounding. It is a compression algorithm. All compression algorithms are some types of logarithmic based. But when you use this logarithmic scale for capacity, if we keep on increasing the SNR, the signal power is compressed. You cannot able to increase the capacity due to the channel. The channel, we know that estimating the channel for this 5G itself is a challenging task. That is a very big area. Let us discuss in some other time. So let us concentrate only on the capacity with respect to the upper bound. Okay. So the SNR, we cannot able to increase at a certain level due to the logarithmic scale since it is compressed. So you cannot able to increase the capacity. Then how can we modify this formula to get a 10 to 50 gigabits per second a date? In the year 2004, there is a scientist who is from Tiruchirappalli. Now he's working in Stanford, Dr. Arokesami Palraj, their team. They have been determined the information capacity for a deterministic channel by replacing this logarithmic scale into a linear scale. What is that? How can it possible to modify this channel information theory from logarithmic scale to linear scale? We call it as multiple input, multiple output system, where if we keep on increasing the number of transmit and number of receive antennas, you can able to create a more multipath. Then you can able to transmit information on this multipath. You can able to increase the capacity. So the simply logarithmic scale is replaced with m cross n. If we increase m number of transmitting antenna, if we increase n number of receiving antenna without increasing bandwidth, without increasing SNR, the capacity will be increased. Theoretically, they proved. You can check with their papers, research papers. So one of the major reasons are the fundamental reason why 5G is promising to provide this much data rate due to this MIMO, or we call it as massive MIMO. Why we call it as massive MIMO? Come to that particular point. Even your 4G is also using MIMO. Then what is the difference between MIMO and massive MIMO? This massive MIMO is one of the technique without enhancing the bandwidth to increase the capacity. Okay, you have to increase the number of transmitting and receiving antennas from 4 cross 4, 8 cross 8, even it can go 32 cross 32, 64 cross 64 like. So you can able to increase the number of antenna elements. You can able to increase the capacity. Now, the next challenge when you are entering into the user equipment. If I want to increase the number of antenna elements in the base station, it is very easy. I have enormous space on the base station side. With the mobile station user equipment like your tablet, laptop, or your mobile phone, do you have a space to incorporate this 4 cross 4 or 8 cross 8? The number of antenna elements are increased. Then the space and the size of the device also started to get increased. So that is the one of the disadvantage, or you can make it more research on it. We can able to receive this much amount of information when your user equipment is ready to adopt this MIMO. Okay. The another method, the signal to noise ratio. This MIMO in 4G is radiating its power like a isotopic, or you can say it as an omnidirectional way. The antennas which are all used for this MIMO with the user equipment, as well as, you know how many antennas your phone has? Almost 2 cross 2 for 2 cross 2 for LTE horizontal polarization, 2 cross 2 for MIMO vertical polarization, and you may have a Bluetooth antenna. You may have your GPS antenna. Like it has many antennas operating at a different band. But this MIMO 4 cross 4 or 2 cross 2 operating on the same spectrum, we know antennas are reciprocal devices. If one antenna transmits, the closer antenna may start to receive, may induce the efficiency of the antenna to get reduced. So that we have to keep a sufficient spacing between the antenna elements. Okay. So hopefully you understand what I mean here.
Yes, sir. Yes, sir.
Yes, sir.
Yes, sir. Carry on.
Yes. Yes. So we have to enhance the data rate. We know in previous digital communications, like a rake receiver, the multipath is a challenge. Multipath is a disadvantage. But this MIMO, this multipath creates enhancement in the capacity. Why? If one channel goes deferred, the closest channel will not feed. This is the concept of diversity. So this MIMO utilizes this diversity concept over here, and it starts to provide, okay, a high capacity. That is the one end by seeing this M cross N. So capacity, instead of growing logarithmically, it grow linearly with respect to M cross N. That is the advantage of MIMO. So linear increase in capacity. Now you have increased the capacity. How can you direct the SNR? So instead of doing like this 4G, like an omnidirectional pattern, we have to direct the beam towards the desired user, intended user, so that the same beam will track the user, okay? Then it serves to the entire service cycle of that particular user. We call it as beamforming. The beamforming may be in the RF site, the beamforming may be in the baseband site, or the beamforming may be in the hybrid. So this is the way the 5G is promising to provide a high capacity by modifying the existing mathematical models, existing channel capacity theorems, to be slightly modified to fit into the 5G environment. Now, when channel information capacity theorem is there, we have various channel modeling analysis like a free space path loss model, Rayleigh model, Ricean model, like that. When you are modifying this particular channel information capacity theorem from logarithmic scale to linear scale using MIMO, we have to adopt new strategies for the channel modeling. So the existing channel models will not help us. So we have to go with some of the stochastic based channel models to analyze the capacity of this 5G networks. Okay. So the targeting the energy to the specific user. So the energy efficiency of the network may be increased. We call it as the beamforming. This is the key technology for both 5G FR1 and FR2 base stations. And also, which promises the safer method of increasing the SNR. As I already mentioned, the word called health and safety concerns of high electromagnetic energy is limited. That's why the mobile operators and the government has been releasing along with this ITUT, that is the Telecommunication Union. I hope you remember 17th May 1965, I think so. This ITUT has been established. The day is called as Telecommunication Day, World Telecommunication Day. That day only our Indian Prime Minister has inaugurated the 5G test bed, which has been collaborative work of IITs and Summit Center. Okay. So these are all some of the key aspects of your 5G, how it is providing or promising to give a higher data rate by means of sacrificing, or you can say that maintaining the linearity limits and the health and safety concerns. Okay.
Yes, sir.
Now we'll move to the realization of this millimeter wave for 5G. When you are realizing your 5G with respect to the FR1A or B band, which is sub 1 gigahertz or 7.1 to 5 gigahertz ranges, there is no problem with the device availability, or the solutions are readily available. You have a lot of research on it. When you're discussing about this millimeter wave operations, there are a lot of advantages. The one advantage I said, you have large bandwidth in the order of hundreds of megahertz, so which will be providing multi-gigabits per second data. Flexible deployment. That is the one of the advantage, which is providing integrated access with the backhaul. And high capacity with dense spatial reuse, as I already mentioned, MIMO, which is using the parallel channels, spatial reuse capabilities. So we can able to increase the integrated access in the backhaul. That is flexible deployment, your 4G and 5G, standalone and non-standalone. But only problem here I mentioned is with your user equipment. It has the dual connectivity. As I already explained, what are the dual connectivity RF challenges we are facing when it is operating at standalone and non-standalone mode. So what are the challenges when we are mobilizing the millimeter wave? For fixed wireless network, we are not talking about this one. Since coverage is not a problem, when you are mobilizing, when you are allowing this millimeter wave for high bandwidth, high data rate, mobile users, the high path loss that is due to the susceptibility to blockage. The electromagnetic waves are blocked, sometimes scattered. And the second one, the device cost. Or you can say in terms of maintaining the linearity limit with the RF power amplifier at millimeter wave frequencies. So these are all some of the challenges. What are the solutions for that? The first solution, as I already mentioned, with respect to your SNR, directing the energy to the intended user, which is called intelligent directional beamforming, where we have to use the signal processing concepts, something like smart antenna. I may not call it as a smart antenna, but it is the DSP processor may be smart, your antenna is not, but it can provide some detailed operations in terms of the intelligent directional beamforming and beam tracking, which will help us to increase the capacity as well as the coverage and continuous connectivity. That is the first solution. Second solution is tight interworking with the sub 6 GHz bandwidth. One is in the order of FR1, the another one is in the order of FR2. How you are going to give the interworking with these two frequencies? How fast you are going to acquire the data? The third one is optimization of the millimeter wave for the mobile users, mobilizing to meet the cost and power thermal constraints. Thermal constraints, as I already mentioned, this the heat produced by your electromagnetic wave when it is moving in the bent surfaces, curved surfaces. Okay, so these are all the different solutions when we are realizing millimeter wave for mobile applications, for enhanced mobile broadband applications. Okay.
Yes, sir.
Hopefully, you got an idea about the.
Yeah, exactly. We got a basic idea and underlying technology. Yes, the Shannon algorithm. And I was just going the older days of my BTech also. We are having the 3 dB graph, the gain versus all these things. And it's an underlying concept, that OFDM. Then, I mean, some interactions we could have, like when it comes to the intersymbol interference, what will be the case of 5G? It will be less, right? The interference of signals.
We cannot say like that, sir. It is less or more like that. But there is a threshold we are fixing with respect to the coverage and the data rate.
And so sir, as you have mentioned one thing, nowadays we can see internet inside the car, like we can see what are the applications? Is it related with this 5G communication? Due to the curiosity from the student side or the faculty or the, on a layman point of view, I'm asking this question.
No, it is not due to 5G, sir. 5G is still in the test bed created. I told you, and I mentioned you that 17th May,
yeah,
have been inaugurated a 5G test bed. Okay, that is for fixed wireless network.
Okay, so
as on now in India, we don't have such a test bed or a prototype models which will be making the mobile users to utilize this 5G band. You know, in India, the spectrum itself, it is obvious, is very high cost.
Yes.
So we are not able to accommodate such a high frequency devices at the user end. Even some of the applications, we need more Wi-Fi hotspots if you want to allow your car to use your 5G network. You know the speed of the car, isn't it? So based on that, you have to provide more Wi-Fi hotspots to cover that particular band. You know, in Japan and China and South Korea, they have been trying this particular application as one of the major challenge. They have been giving connectivity in the high-speed trains, metro trains. You know the speed, it is almost 500 kilometer per hour to 600 kilometer per hour. Do you imagine how many Wi-Fi hotspots they may be fixing at that particular frequency ranges to provide continuity access of your wireless inside the car or inside the train? Just imagine the same concept inside your car. You are moving with around 120 kilometer per hour. Okay, you are crossing that 1 kilometer within that particular period, but within a particular say 5 minutes, 10 minutes. How many hotspots you need, Wi-Fi hotspots, to provide a continuity in the connection? So we have to check all the challenges and how far. And the technologist must understand one thing: between the base station and the user equipment is the only connectivity in wireless. The base stations are connected with the servers and the remaining mobile switching access and the switching centers, everything through cables. As I already mentioned, at least 70% or 75% of the cables must be fiber optic to meet up this particular speed. Otherwise, it is very difficult with the coaxial cables to providing such applications. So fiberization is one of the major requirement to deploy the future wireless networks, either it may be 5G or 6G.
So I think it was a quite in-depth technical session, and we all enjoyed actually. So actually these sessions are mainly for a community purpose, like helping the students. So altogether, when I interacted with Professor Dr. Gunasekaran, he was very much interested to be a part of this community activity. As he has mentioned earlier, now he's working in Oman. The thing is that he's from Tamil Nadu in India. The main mindset is that we have to enable students to come into the forefront to explore the opportunities or the technology. I'm just asking this question based on a layman point of view, not on a technical point of view, because when we are traveling, we'll be thinking Morris Garage, Internet Insight, all these concepts. The students must think in that, but because on seeing a car, they must think what are the underlying technology, and while connecting, while moving, we know that hands off will be happening from cell to cell movement. So with the 5G, that will be quite far, and latency will be increased. And as Sir has mentioned, the throughput and all these technical terminologies, and a lot of as Sir has mentioned, now the 6G will be coming. And what are the more like challenging projects we could explore in this area?
Sir, even students can take up a simple Chanan Hartlila. They can check replacing the logarithmic scale with the number of antennas. You can use 2 antennas at the transmitter side and 2 antennas at the receiver side. They can simulate a model using a simple MATLAB technology, MATLAB software. They can prove that the capacity in a deterministic channel is increasing linearly for the given SNR.
And when Sir has mentioned regarding the spectrum, I was thinking the spectrum sensing algorithms are there. Like we are having the primary user who are paying for the band. And when a secondary user, when the primary is not using that particular band, a secondary user can use it. Yes. And a lot of things. And we are having the spectrum case also. So it's a huge investment is coming for that. And this communication is also increasing and improving. So on behalf of this forum, I congratulate and wish all the very best for Dr. Gunasekaran Tangavel for his innovative approach towards this project, and while sharing his ideas with the students and for the community. This shows us the good heart of a person, like his willingness, and we can see the teaching methodology he was doing. Like I was really enjoying this session. That way I told that we can have the interaction in the end. So thank you, sir, for spending your valuable time. I know that we are not using the office time. We are using the night time in India as well as your place also. With all the other schedule, we are using it for the community purpose only. So thank you for sharing and spending the time with us. So thank you, sir. Thank you.
Thank you for the opportunity. Okay.
And I hope that we will be collaborating with our like students further benefits, like we can have some interdisciplinary projects also regarding this communication, as well as artificial intelligence and all, like interdisciplinary projects, or we can have some like patents, publications. Everything is possible. So thank you, sir. Thank you.
Thank you. Best wishes. Thank you, sir. Thank you.